Hey there, if you're just joining us for the webinar on HABs, please hang tight. We will begin the webinar in just a couple of minutes. Hey, good morning or good afternoon, depending on where you're joining us from. Thank you so much for coming to learn about harmful algal blooms on the national stage and in Louisiana. I'm Emily Mong Douglas. I'm with Louisiana Sea Grant, where I'm our public engagement specialist. And yeah, this is the first part in a two-part series on harmful algal blooms. The next installment will be November 3rd, so mark your calendar. And stay tuned near the end of the webinar. We will give information on how you can register for that second installment of the series. So without further ado, we're going to get into the content that you've been waiting for. So we've got a great lineup of guest speakers for you from the EPA. We're going to hear from Johns Ravencroft talking about water quality criteria and swimming advisories that the US EPA has for cyanotoxins. From Rick Stumpf with NOAA, we're going to be talking about the use of satellites and harmful algal blooms. Nia Renee from NOAA will be sharing with us about the phytoplankton monitoring network, which is really cool if you haven't heard of it before. And then finally, we're going to be hearing from Brady Skaggs with the Pontchartrain Conservancy, who will be sharing about HAB monitoring in Lake Pontchartrain. And then we're going to wrap everything up at the very end with a question and answer session with all of our guest speakers. So we're going to wait until the very end to ask all of the guest speakers our questions at once. However, while I'm going to ask you all to stay muted this entire webinar, please feel free throughout this event to drop your questions into the chat box, and our guest speakers will get to them during that Q&A session at the very end. All right, so with that, I'm going to ask for our very first guest speaker to take it away.
Thank you, Emily. Here, let me start sharing my screen. And, hopefully this works. Emily, can you see the slide now? Yeah.
Oh, yeah, looks good.
All right, thank you. I'm going to stop my video, so I don't know if my internet will be steady, so I'm just going to go ahead and stop the video. All righty, well, good morning, good afternoon, everyone. My name is John Ravenscroft, and I'm a microbiologist at EPA headquarters in the Office of Water. And I wanted to thank Emily and the Louisiana Sea Grant for inviting me to speak with you all today and present on HABs. And I'm going to talk about EPA cyanotoxin criteria today. And I'm happy to be here with you all. And if you have any questions, as Emily said, we're going to talk about or have a Q&A at the end. Let's see. So just a quick disclaimer, this is the legal part. I'm here at the EPA, but the views expressed are those of the authors and not necessarily the agency. So, so I'm going to break this down into two main parts today. And one is a little bit of background information on the development of the criteria and the swimming advisories, and then talk about how we, the process for developing the actual recommendations that we made back in 2019, and with the issuing the final recreational criteria recommendations. So a little bit of background information on these criteria. Back in 2014, there was a really severe bloom on Lake Erie, and the toxins that it made was microcystins, and those got into the system in the city of Toledo in the drinking water system, and there was a need to have some recommendations in place to say what what a safe level of that might be if it happened, if those toxins happen to get into drinking water. Into your drinking water. So EPA in 2015, in response to that bloom, EPA published three health effects support documents that describe the human health effects from exposure to these cyanotoxins, and the three were microcystins, cylindrospermopsin, and anatoxin A. And based on the science that was available at the time, EPA then issued two drinking water health advisories in 2015, that were one for microcystins and the other one for cylindrospermopsin. And they're available at this link that I've included on the slide here. And those were for, dealing with potential toxins that might be introduced into a drinking water distribution system. And once those got out, we received questions from various places about, well, you can be exposed to these blooms and the toxins in surface waters as well. So, what do we do about swimmers or fish consumption when these blooms happen to occur in a surface water body? And so we then initiated development of values using the latest science available to protect primary contact recreational use. And that's a long way of saying we wanted recommendations that would be that would provide safe public health protection and say if it's safe or not to be swimming. So we worked with a variety of stakeholders during development of the criteria, and such as the states and public health agencies and various other groups to to talk about the various components of what would be helpful and what would work well for various applications. And I just wanted to real quickly, so you'll see this AWQC/SA, and what that stands for is Ambient Water Quality Criteria or Swimming Advisories. And I work for the government. We love our acronyms, so that's what that means. I'm going to refer to that as criteria or our recommendations, EPA's recommendations throughout the talk. But basically, and I'll talk a little bit more about why we're using ambient water quality criteria / swimming advisories, that sort of format here in a few minutes. But just so that when I mention criteria, I'm referring to this sort of designation that we have. And the reason why we have this AWQC/SA is because we wanted to make these available for states to use as either what we call Section 304A recreational criteria, and that's a particular section in the Clean Water Act under which EPA issues criteria recommendations for states to use, or these can be used directly as swimming advisories, or both if a state wishes to do that. And the reason why we made that distinction is because at the state level in many states, the Clean Water Act functions for these criteria or for water quality standards usually occurs in a particular agency like a Department of the Environment or something similar to that, whereas swimming advisories tend to be used by state health departments to post beaches, to protect public health at swimming locations, that sort of thing. And the one side, the Department of the Environment side of the application of these criteria usually takes a couple of years to develop standards. They might need to go through the state legislature for approval and then to EPA for approval. And that could take a couple of years sometimes, whereas swimming advisories could be picked up by the Department of Health and used to protect folks at the beach fairly straightforwardly. And so we just wanted to provide these for either sort of application so that we could help, help states protect the public from HABs at beaches in particular. So if these are adopted as standards and approved by EPA, they can be used for all Clean Water Act purposes. But if states just wanted to use them for swimming advisories, their Department of Health could pick these up and use them for beach notifications. And so our development of the criteria used the peer-reviewed information, such as what we published in the health effects support documents back in 2015, as well as relevant studies that we found pertaining to recreational water, surface waters, and recreational exposures. And so we used that information to develop recommended values for both microcystins and cylindrous spermopsin. So there are two numbers, one for each. We use the agency recommended rec exposure values in a scenario which includes immersion and incidental ingestion. So unlike the drinking water health advisories, which focused on drinking water, like purposeful ingestion of water, like drinking water, what we try to characterize here in the criteria was what you call incidental ingestion. So this is water that you ingest while recreating, whether you realize it or not. So there's always some small amount of water that you ingest, and this is what we term incidental ingestion. And we evaluated the science describing those health effects from exposure to the cyanobacteria cells as well. So we looked at the cells and we looked at the toxins. And this is the conceptual model that we followed as we developed the criteria. And so what we call stressors, that's a fancy way of just saying these are the things that we're worried about or that can cause health effects that we want to avoid. And so there's two main bins of stressors. Or the one bin is the toxins that the cyanobacteria cells can produce. And these are, in this case, cylindrous spermopsin and microcystins. And then the other bin is the cyanobacteria cells themselves. So exposure to the cells can result in what we call inflammatory response effects, things like almost like an allergic response where it can manifest as a rash on the skin, or it could, if it's inhaled, the cells are inhaled, they can cause asthma-like symptoms. If they're ingested, they can cause GI sort of symptoms, so things like diarrhea or upset stomach or nausea, that sort of thing. And those tend to be considered separate from the endpoints of the toxins. For instance, with cylindrospermopsin, the key adverse health effect, the endpoint, if you will, here at the bottom is kidney damage. And for microcystins, the key endpoint of concern is liver damage. And those are the dark gray boxes. And in the light gray boxes you'll see on this conceptual model are the things that we considered, but may not have had enough information to consider quantitatively, so they were considered qualitatively. And so there is evidence for these, for both toxins, for reproductive effects, developmental effects, such as fetal development, and also some information that might suggest that these could be carcinogenic. But again, the strongest evidence that we had, the quantitative evidence, we relied on the liver damage or kidney damage endpoints for microcystin or cylindrospermopsin, respectively. And that's so when we're talking about the values that were derived, we base those values on the endpoints that you'll see here. And so we initially published a draft back in 2016. Then we had a public comment period that closed in March of 2017. We received comments from about 52 entities, and that included states and a tribe, a tribe located in California, industry representatives and consultants and environmental organizations. So we looked at all the comments that came in. We tried to respond to them as best we could, and we revised the criteria based on those comments received. And then we issued a final recommendation for the criteria and a response to comment document in May of 2019. And both of those documents are available on our website. And I've got a link later in the slides, but you can also just Google EPA's cyanotoxin recreational criteria, and they'll come up, one or two on the list. So let's talk a little bit about the final criteria recommendations that EPA issued back in 2019. So in response to the public comments, we issued or incorporated new more scientifically robust children's ingestion data. So one of the challenges that we have for recreational exposures is a limited data historically. But we were fortunate that during the public comment period, there were studies that were published that provided much better incidental ingestion data that also allowed us to examine ingestion and exposure for younger children, older children, and adults. So we incorporated those new data into our revised criteria, and this allowed us to provide additional detail on the daily ingestion rate, for instance, for younger children that we did not have previously. And so these studies were enormously helpful for this effort. And we added additional information and detail on the tox studies. So the RFD, the reference dose, is a very important part of being able to develop the criteria recommendations. And so we added more information to provide additional detail on the development of that reference dose. One of the items that is typically included in criteria are relative source contribution. And that's just saying, like, think of exposure as a pie, and you get this slice from this source, and another slice of exposure from another source, and so on and so forth. In the draft, we tried to allot or allow for other sources to be a part of the exposure, but the question that we had was, is that relevant, considering that we're talking about recreational exposures? And the question we're trying to address specifically here is the water safe for swimming? And so when we revised the criteria, we focused solely on the recreational exposure. And so we didn't include a relative source contribution. And we also modified duration and frequency recommendations. And then we provided a toxigenic cell density value that states could use as a tool to help manage and monitor their waters particularly for microcystins. And toxigenic means that, when you look at a cyanobacteria population, some of them possess the genes that can allow them to produce the toxins. Some of the cells in that population don't possess those genes, and so are not able to produce the toxins. And so when the cells that possess those genes are called toxigenic cells. And so one of the ways that this could be helpful is if you know that there's a elevated population of cells in this of cyanobacteria present that could produce toxins, that could mean that you could have a problem in the future, in the near future. State of Ohio looks at these toxigenic cells, and they found about a couple week lag between the elevation of the toxigenic cells and then the appearance of an elevated level of toxin. So it allows them to, more information to help them better manage their water bodies and protect the public health that way. One of the pieces that we've included in the criteria here is children's exposure. And we base the criteria on children's recreational exposures. And this little guy here on the right, if one of the things that gets me every time I see this picture is his little footprints in the green scum leading up to the water's edge. And so, he's covered with green slime from this HAB that's going on in this lake. And so one of the things we notice in the literature is that children experience a disproportionate share of the incidents during HAB-associated outbreaks. And so when you look at the number of outbreaks that occur and the people that are involved in those outbreaks, about 2/3 of those folks involved were less than 19, 35% were less than 9. And 80% of all the confirmed illness reports and freshwater cyanotoxin exposure involved kids. So the evidence shows that kids tend to share a disproportionate amount of the health effects. And part of that is due to the greater exposure that kids have compared to particularly younger kids compared to older kids or adults. And younger children can be more highly exposed. They ingest more water. They spend more time in the water than others. And because of their lower body weight, they can have a higher dose, if you will, or a higher, exposure to the toxin. And you can see on the graph here, when you look at the incidental ingestion, recreational ingestion, that the 6 to 10-year-old group separates out quite a bit from the 11 to 17 or the 18 and overs. And so we utilized this recent study by Dufour et al. In 2017 during the revision before the final was released. And in the final recommendations, we combined both this data you see on the right, which is the distribution of exposure of ingestion, with the time spent in the water to come up with a combined distribution of ingestion, recreational ingestion for kids 6 to 10. And that number is down here at the bottom of 0.21 liters per day. And that allowed us to calculate doses that the children were receiving. And so I talked a little bit about the relative source contribution already, so I'll just keep on going. So the other piece of the criteria, there's a magnitude, that's the number, and then there's a duration and frequency. We provided additional rationale and relevancy for the duration and frequency recommendations. And as I said at the beginning, these criteria consist of a ambient water quality criteria recommendation as well as a swimming advisory guideline. And for a swimming advisory, we recommended that the toxin values not be exceeded on any single day. If you monitor and you get a hit above the recommended values, we would recommend that you post the beach and prevent exposure, particularly for kids. And then for the water quality criteria, we recommend that the toxin values not be exceeded in more than 3 10-day assessment periods over a rec season in more than 1 year. And part of this is that HABs can occur naturally without human intervention. But human activity can encourage HAB formation. And we see this in various water bodies across the country, that our activities can encourage HAB occurrence and maybe increase their severity. So what we want to recognize here is that these recommendations, when they're applied, we want to be able to recognize a pattern of occurrence. And are these HABs occurring more frequently? Are they more severe? And so using these 10-day assessment periods helps to evaluate the water body to see if these HABs are occurring more frequently and they're more severe than what we would consider to be safe or supporting that designated use of the water body, which is recreation. And so if you get more than 3 exceedances during the year, and then those exceedances occur across more than 1 year, this is in the frequency column here, then there may be an issue with that water body not meeting its designated use. And so in this chart or this table, the 2 values that we recommended, one for microcystins, which is 8 micrograms per liter, and then cylindrospermopsin, which is 15 micrograms per liter. These are the values that we recommended states use to be protective of kids. And if you're protective of the younger children, you're protective of all recreators in the water. We also looked at the cyanobacteria cells, and the cells are challenging because they're commonly associated with outbreaks of exposure to HABs, and one of the most common responses that people have reported are those inflammatory responses, rashes, for instance. And we looked at the health study data that was available. And so we have epidemiological data, we had clinical data for volunteers looking at effects on volunteers. And then also we looked at the outbreak data that was available. And the challenge is that each HAB is a little different. There are different combinations of cells and species, and whether the cells are toxigenic or not. And so you get a different response, or the response is not consistent from site to site or study to study. And so we have this range that we've noted in the literature of 5,000 to 100,000 cells per mil that seems to kind of bracket where the health significance of the data. And what we recommended was what we discussed in the document was that, the upper end of cells that states might use, and a lot of states do have cell guidelines on their books, is that they be below 100,000. And if they are, then there's science available to support those existing cell counts that various states are using. And then we also looked at the toxigenic cells, and we were able to calculate a cell density of 40,000 cells per mil of toxigenic microcystis based on the value of 8 micrograms per liter that we recommended. So those 40,000 cells, if they were producing microcystin, could result in that 8 micrograms per liter concentration in the water column. That would be the limit of what would be considered safe. And with that, I'm finished, and we'll wait to the end for questions. But here's my contact information, and also EPA has a CyanoHABs website that my colleague Leslie Dungalata worked on. It's got a ton of good information on there. It's a good website. I encourage you, if you've got questions or want to know more, please visit the website. And thank you very much for your time today.
Great. Thank you so much, John, for that presentation. So we just heard a bit about those different standards and how they play into human safety. So now you might be wondering a bit about, well, how can we forecast or detect when HABs are happening? What types of technologies are out there? So we have Rick Stumpf with NOAA, who's going to be sharing a bit about that. All right, take it away, Rick.
Okay, thank you. My screen up okay?
Yeah, it looks great. We can hear you well.
All right, great. Thank you to be here and participate in this session. I'm going to talk now on monitoring for emphasis on the satellite data. There's any number of ways to monitor, and you got a sense of that with toxins and the like. But a key part is knowing where there are blooms to begin with. So a state or such can plan accordingly as to where to sample and when to sample and how to respond to lakes. And make sure this clicks. Okay, so satellite imagery has been used on and off for a while to detect blooms. Louisiana, give an example on the left side, which actually goes back to an event when the Bonnie Carey Spillway was opened in 1997, and the reddish areas in there, or the pink red, are surface blooms would have been appeared as scum. With the satellite on hand, you couldn't actually get a green color, but the infrared bands show it quite clearly. Another example is with a different satellite more recently, where a chlorophyll algorithm was tuned in order to pick out the blooms that occurred during a 2009 event. So different events have been shown in the past with these satellites, but there has not been consistent monitoring, partly because of resolution and variations between satellites and their ability to pick up different things. I would note Louisiana has a lot of algal blooms, what with the Mississippi River coming through and also splitting into off to the Atchafalaya. There's a lot of nutrients and they produce all kinds of blooms. Example here from the satellite is we have the chlorophyll in this case, and you can see blooms all over the area. And then an example here with cyanobacteria specific, and you can see Lake Bourne and right in those areas, some of the blooms are specifically cyanobacteria. These could be mostly freshwater, but you can also get marine cyanobacteria as well. Not all cyanobacteria are toxic. You heard a little mention to that about toxigenic cyanobacteria in the previous talk, but this is at least the first indicator. And just to put a context, this is the true color image for the same time, so you can get an idea of the patterns. The overall pattern, what we're doing with satellite is we're working with primarily the ocean land color imager, OLCI, on the Sentinel-3. That's a Copernicus satellite. The program was developed by the European Union. It gets about 5 to 6 usable images a week. It's nearly every day, but you can get some sun glint that takes out, say, one image. This, of course, assumes that there's no clouds. We don't have the ability to see these blooms through clouds. So we at least need relatively clear conditions, but it captures that. 300 meter pixels, and there's enough key bands allow us to be pretty specific about chlorophyll and cyanobacteria as compared to things like sediment, for example. There's some other satellites out, MODIS, which I mentioned before. It's an older satellite. Back there, the MODIS on Terra is now was launched 23 years ago. And they're on their last, their orbits are starting to deteriorate, rather remarkable, but 1 kilometer data, and does not have a couple of the bands that OLCI does have. There's a higher resolution, Sentinel-2, the multispectral instrument. It can pick up chlorophyll, but there's really not a lot of work done with it. But it goes, and that's an opportunity for much smaller water bodies with a 20 meter pixel. It's only every 5 days with a repeat, but there is work going on now. We're starting that, as well as a number of research groups looking into how well Sentinel-2 can be applied. But the routine most effective is the OLCI. We started our work with its predecessor, Maris, and Lake Erie, and the two are pretty much comparable. And just to give you an idea, particular bloom in Lake Erie, really intense. You can see the bright green in this area and how that maps out with the bloom. But notice that like sediment and this lake and the plume do not show up with the algorithms. We sort those out. The reason why with the spectra is of course, this is from blue over to red to near infrared. The green shows up quite clearly, very bright green reflectance. But then we get these pattern down here where we pick up a chlorophyll A absorption, and this is phycocyanin absorption here. So these are the two key factors, looking at chlorophyll A specifically and looking at phycocyanin. So these wiggles in this area are what we work with in order to pull the information out. If we were over in the, say, the blue wavelengths, there's a lot of other material, tannins in the water, dissolved and also in particles that would affect the signal. But these wiggles are specific to chlorophyll A and phycocyanin. So working with those allows us to be to target it. That's the key advantage of the particular sensor we're using. Just to touch on another side with bloom forecasts, we do some in Florida. I'm talking cyanobacteria, but we do work on truly the marine ones. Cornea brevis, which fortunately has only been in Louisiana a couple of times, blown over there by hurricanes coming from Florida. And we do those comparisons with cell counts, and we identify the blooms. We don't right now spend much time moving them around, but we have the ability to do so. And again, I note that when they have occurred in, when Florida red tide has shown up in Louisiana as a result of hurricanes, but it's rare. Texas does get them sometimes. There's not been a red tide in Florida for about, in Texas for about 4 years, partly due to it's one of these unfortunate things, hurricanes dropping a foot or two of water in August or September, and it doesn't like low salinity water. So the blooms have not gotten established there, but there's a risk they could come up, possibly up as far as Lake Charles area. Okay, just to show in Florida again, with these bands, if you look here, unlike the Lake Erie image where the blooms were bright green, it's not terribly obvious where the bloom is from a true color image, but we can pull that out quite easily with using the wavelengths to specifically target, again, chlorophyll A versus other materials. So there's no squinting at the image trying to figure out where the bloom is. And we do have a monitoring system here as well that you can access for different ones. We use chlorophyll fluorescence for cornea, which is chlorophyll. Most algae, true algae, do fluoresce, and most of the time. And so we have the example of a cornea bloom over in Florida, but then we have a diatom blooms off the Louisiana coast that are also fluorescing. So there needs to be a context in order to separate those out as to what's going on, whether it's information from cell counts or the like. And occasionally there are large blooms off of Florida, and these large blooms that go up to the panhandle are definite risk for Louisiana area, but you can capture information on the scale of such blooms. These are some different years that had exceptionally large blooms that are up in the panhandle area. Again, we do forecasts of these, and we include intensification, the satellite imagery, and combine those with cell counts. And we try to work with a number of states on this area in that regard for these types of blooms. Now, the monitoring page we have, I mentioned before, we include several areas, including Louisiana, eastern Louisiana, and most of these are for cyanobacteria blooms, because those tend to be the major concern. And these are the types of some of the areas we cover around the country. A close-up of that for Lake Pontchartrain, specifically Louisiana. This is an example, it's from 2 weeks ago, and you can see the true color image and also pattern for cyanobacteria in the area. And there's not very much. It's a pretty faint bloom, but some of the other lakes do have some. I think that's Lac d'Alemande as well, and some of these other lakes do have blooms that tend to persist for long periods of time. The way we do the products they are geotiffs. This particular one is a pretty picture, but the geotiffs can be downloaded, and they look the same as, pretty much the same as what we see here with the color table. And that means it's possible to view them in a GIS software and do analysis and superimpose data or extract data and information from them as well. We've been working on metrics for these, and the question is, people ask the questions, how severe is a bloom and how does one water body compare to another? Examples, so we look at both the quantity and duration for this for a severity metric, which is effectively the average concentration in the lake during the season. And so well, in Florida, Lake Okeechobee has the largest blooms. It's also the biggest lake, so it does not necessarily have the most severe impact from the point of view of being covered. Whereas some of the smaller ones, like Hancock, has incredibly intense blooms, often several hundred micrograms per liter of chlorophyll. And Lake Apopka, similarly, which is a large lake, has a pretty steady bloom. But we have the capability for that. We're in the process of just now completing a national assessment of this, which will include lakes all over Louisiana as well for that. We've been doing work with in the CYAN project, the Cyanobacteria Assessment Network. This is a multi-agency project. US EPA was the lead on this for freshwater lakes, but it involves us, NASA, and USGS. And the algorithms we've developed, we transferred over to NASA for processing, and then there are tiles around the country that can be extracted with and analyzed from this data set. EPA is putting them in the Enviro Atlas as well, and it does go back into the MERIS data set, which is 2002 to 2011, and then OLCI, which starts in 2016 as well. So there's a longer time series. There's actually an app, an Android app that you can get on your phone that can allow you to check on a status of a point in a lake of interest or water body of interest for cyanobacteria. This is the tiles that you see here that are used in the black points or the lakes that are all retrievable with the OLCI data. There's around 2,000 lakes around the country that fit this description, and that does include some coastal or coastal plain lakes in Louisiana. And now, just to capture a better sense in your area what a time series might look like for a bloom, and this is last year. There's between Lake Pontchartrain and you can see the development of a bloom from July through August 23rd and example pattern, what your color looks like. In this case, if it hits the yellow or particularly the bright red, in most cases when we're at a bright red concentrations, if it's a microcystis bloom, you're usually getting scum formation in those areas. There's always a risk of them when you're at the yellow level. Satellite sees between a few centimeters to perhaps a meter, depending on how clear the water is. And obviously, if there's scum on the surface, there's not much depth. So Louisiana, the water is generally turbid. So what we're capturing is the surface concentration of the blooms with these. These are the type of patterns you get. And that wraps that up. If you need to contact me or if, you have my email address there. And again, you can monitor what's going on in Eastern Louisiana with our HAB monitoring system. Thank you very much.
Great. Thank you so much, Rick. Next up, we've got Nia Renee from NOAA. And while Nia is sharing her screen, getting ready to talk about the Phytoplankton Monitoring Network, I do want to give a special shout out to Betty Stogler and Monica Wilson of Florida Sea Grant. They were instrumental in helping me create the framework for this webinar, and I just want to give a huge thanks to both of them. As you might have known from an earlier version of the agenda, Betty Stogler was set to be one of our guest speakers. But because of where she's located in Florida and damage from Hurricane Ian, she was unfortunately unable to join us. But we do have Monica Wilson on the webinar today providing tech support. So I just wanted to say thank you to Monica and to Betty for their support throughout this process. All right, Nia, you're up.
All right, thank you for the invitation to speak here today with everyone. I'm really excited to talk about volunteer monitoring. So we have listened to a few talks, and just to follow up on what Rick communicated about, we're all looking to monitor harmful algal blooms, but my program, the Phytoplankton Monitoring Network, is geared towards relying on the help of volunteers on the ground to monitor their coastal surface waters. So my name is Nia Renee. I'm an environmental scientist here in the Charleston branch of NOAA NCOS in Charleston, South Carolina at the Hollings Marine Laboratory. Within the Stressor Detection and Impacts Division, and I work with the HAB Monitoring and Reference Branch. And that's why we use a lot of acronyms, because there are many words, many titles that have to be said with NOAA. So I work with Dr. Steve Morton, who originally developed this program almost 20 years ago, or over 20 years ago. And I'll talk to you about how we work with volunteers throughout the US to monitor harmful algal blooms. Okay. Okay, so the network is composed of 4 components so far, and it's continuously expanding based on its application. We have a coastal component, monitoring estuarine systems and marine environments. We have a freshwater component here, and John earlier spoke about that, and it's very similar to what he spoke about, monitoring freshwater bodies. We have the aquaculture component, from which I am the coordinator for, and we have the tribal nations component. And so in all of these aspects of NOAA PMN, we're looking to partner with people and learn from the community so that we can work together in a more effective and efficient way to monitor harmful algal blooms. Okay, and recently we have shifted focuses to on diversity and community science participation from a broader group. And so we have an urban outreach component, which highlights coastal ecosystem services in areas that generally people aren't going to the coast and don't access the coast as frequently, but they, as far as swimming and recreational purposes, but they do use it for other ecosystem services, like cultural purposes and things of that nature. So to bring their attention to the coast, regardless of what kind of geography or geology they are living in. And we also have the Latino outreach component, which helps to overcome language barriers when communicating with the coastal community about doing environmental science and monitoring the coastal waters. Okay, so I'll talk about what exactly we're doing. So we work with citizens and provide training. So we'll teach them how to use a microscope, how to sample their surface waters for algae, and how to identify the particular species of concern or that could be that are potentially problematic in those waters. And so we'll teach them on how to collect those samples, take it back to the lab, in addition to other water quality parameters such as temperature and salinity. And then those volunteers will go back to their labs and analyze those samples. We have a very comprehensive way of identifying and using broad terms and identifying species down to the genus level, at least, and learn from who we work with so that we can find even better ways of communicating the science. Okay. So if you haven't done so already, you can download the Phyto app, and that's an app that helps train citizens on, and just the community on essentially what they're looking at. We have a finite list of species of concern. However, you may find many other things. And so we don't want your curiosity to just stop there at what's harmful, but also explore what else is in the waters and keep us up to date as to what you find and how long those specific species persist in the water body and what's the general algal community in your area. So this has been used in 150 countries so far, and the data is sent to our database where we'll do quality control, quality assurance. So for every species or cell found, you can take a photo of that, send it to us, and we'll use that to assure that you have ID'd the species correctly. And so state officials notified 15 bloom notifications over the past 20 years and 500 blooms discovered. And this number it's ongoing, as there have been several more over the last few years. And we're currently in 67 states. 36 states, excuse me. It's not 67 states. So 36 states throughout the US. Okay. And so what materials supply to PMN participants? We provide them with a refractometer, a thermometer, 20 micron plankton net, pore size. So the pore sizes within those nets are 20 micrometers, gridded slides so that it'll be easier to analyze your sample without repeating certain areas, and ID sheets and info on the targets that we're looking for, and shipping supplies. So whenever there is a target there in high concentrations or even in low concentrations, but potentially toxin producing, we would ask volunteers to send that sample to our lab at the Hollings Marine Laboratory and provide all the equipment that they need. So reduce barriers for monitoring. And so the Coastal PMN program was the first of this phytoplankton monitoring network. So we've been training science community members throughout the coast of how to monitor their coastal waters, and they can select whichever one that they're nearest and do this on their own time. We asked for at least twice per month, but you can do it as frequently as possible. You can even do weekly or monthly. Okay, just as long as we keep a good understanding of what's taking place and how the algal community is changing over time. And that is the power of relying on the citizens and the community members of the United States. They keep us aware of what's taking place. And the data collected can support programs like for remote sensing, as Rick communicated about earlier, to try to corroborate that information at the time. So this is an image of volunteers at the University of Georgia, the aquarium, and they have been the longest participants in the coastal program. Okay, then we have the freshwater aspect of PMN. So once again, we'll train people to understand how to identify the specific species on our list. It's a very short list of 5 for freshwater. And this will help us generate the data required to either escalate this information and report to the local governing agencies or EPA. And this began with an interagency agreement with EPA Office of Water. And there are currently 25 active sites and 5 target cyanobacteria. And so on each of these slides, you see quotes from volunteers. So it's always best to see it and hear it from their perspective as to what this program is doing for them and what impact it's having on them directly. And so it helps support key decision makers in their efforts to allocate resources for lake health. Without this program, we were swimming upstream. Okay. All right, so that's some of the benefits there. So we also have the Tribal Nations PMN, and this is an initiative that began in 2013, working with having tribal partnerships in southeastern Alaska. You see 3 different sites here, the CTOR, Cultural Science Efficiency, the Chugach, Regional Resources Commission, and the Norton Sound Health Corporation. And so I still got to work on pronouncing these things correctly. And it's very important when communicating with others and understanding how to address them in the appropriate way. So this, a quote from a native village of Opik Akinga, who's native to the village of Diomede. The tribal partnership is the first project that actually allowed us as a tribe to have input in the project design to protect the health of our people. I'm so excited to be the researcher, not just collecting samples. And that's the key part there. This program will not persist without giving the control and the power to volunteers to lead the way in monitoring and becoming better and better at identifying what they see and then ringing the alarm and letting us know what's taking place so that we can take action or alert the appropriate organizations. Okay, so so what we've been working on over the past 10 years is to establish these monitoring programs in laboratories throughout Alaska where subsistence farmers are at risk of illness or death because toxin levels are unknown. Okay, so tribal organizations take the lead in this initiative. NOAA advise and collaborate, and then transfer toxin testing capacity to each region through support services, and in hopes to reduce the risk of illness and death. And since this program has initiated in the regions in which monitoring is taking place, there has been no reports of illness or death from saxitoxins or the toxin of interest in that region. So that shows the power of volunteer monitoring and the power of communities coming together and making sure that their coastal waters and aquaculture are safe for people. So here is also Harvey Kitka of the Kagwatan clan communicating about the importance of aquaculture and food for his community and their traditions in harvesting. And so it's important that they're not at risk of any sort of illness or threats associated with harmful algal blooms. And so this monitoring program has quite large implications in these areas of subsistence farming. So the Aquaculture Phytoplankton Monitoring Network is the newest addition to this program, and it stems off of the work done in Alaska, but expands it to other areas, specifically targeting aquaculture sites, whether it be hatcheries or growing or grow out areas. And it expands the scope of this community science approach to include assistance from aquaculture farms. Okay, so we'll catalog existing and new phytoplankton species responsible for shellfish injury. Like I said, we have our list, but we're constantly listening to the participants to let us know what they see and the impact that it could be having on shellfish or finfish, and establish a national monitoring platform operated by aquaculture farms. And so this program is in hopes to provide an early warning of potentially harmful or toxic blooms. So they're on top of it, and they'll have a time series of how the algal community changes over time. So this is just a display of what we've done so far in the fiscal year 2022. We have focused on areas in the Northeast, Long Island, and in the Gulf of Mexico. And I've just highlighted some sites that we have in operation right now. And one success story is to know that one of our hatcheries, or one of the farmers who are volunteering to provide this information to us, tested their water because they had a mass larvae die off, and tested their water to see which phytoplankton were there. And they were able to switch the water inlet to their hatchery to a different source. And they were able to save the rest of their larvae because they were able to identify what species was available. They sent us the sample, we confirmed that identification, and they were able to save some money. So we're hoping to add on to that and to support more farms and growers in that way. The more they know, the better they can handle the situation before it becomes deleterious to their business. All right, so there are many benefits of monitoring. Early warning system, create a working relationship with growers and farmers, and monitor for HABs during entire shellfish or finfish life cycle, and establish a baseline list for harmful algal cyanobacteria species. Okay, and amongst promoting public awareness and education on HABs. Okay, so just for the last component here, we have outreach in the Latino community to increase STEM diversity in Latino communities. And my colleague, Jennifer Moucher Fuquay, who couldn't be here today, but she was able to work with Latino Verde to translate the methods of the Phytoplankton Monitoring Network to Spanish, so that it reduces those boundaries of participation when you can speak the language and accomplish the same goal. We're all trying to monitor and keep awareness flowing of what's happening in the waters. So there's further communication with Cabrillo College, and Texas A&M University of Corpus Christi to support this Latino aspect of the PMN. So we were also awarded the 2022 Diversity and Inclusion grant from the Office of Aquaculture. This was from my work in New York. And you can see students from South Brooklyn High School monitoring HABs at the Gowanus Bay. We partner with the READY Center, which is the Resilience Education Training and Innovation Center, to provide support for the mitigating the effects of HABs in urban communities, and aquaculture, as many, there are small efforts to increase aquaculture in urban areas. And so we're there to support that effort, mainly for kelp growth to try to impact the water quality, and galvanizing participation from diverse groups of young people in urban areas. This is to enhance job readiness in the blue economy and promote more exposure to the coast in urban areas, and highlight ecosystem services in addition to harmful algal blooms. Okay, so since then we have partnered with the NOAA Center for Earth System Sciences and Remote Sensing Technologies this summer. They had a cohort of students participate in monitoring algae in waterways in New York City's urban area, as well as using satellite data to correspond to what they see. So that was an exciting project, and we expect that to grow over time. Okay, so we have invested in the scanning electron microscope. So there is a new one, and this one has an EDS attached to it, which is the energy dispersive X-ray spectroscopy. And so the scanning electron microscopy helps us improve our capacity for taxonomic identification, especially for diatoms like Pseudonychia, which it's impossible, or not impossible, but very difficult to differentiate one species from the next, or a toxin producer from another without using a scanning electron microscope, which can achieve magnifications up to 350,000. But we only need to go up to about 20 to 25,000 to get this kind of imagery. Okay, so this is Lake Coatepec. Okay, I definitely need to work on that. And in this area, there was a question about whether there's an algae bloom or not, because there was this cloudy appearance on the surface water in El Salvador. This is a crater lake in El Salvador. And so a sample was sent into our lab, and Steve Morton and Andrew Schiller worked on this to image the specimen, which was later found out to be a crystal, using the scanning electron microscope. So many questions can be answered in addition to monitoring for algae. So it'll keep our volunteers engaged in the process of water quality. Okay, and so you can just see here the different screens for elements using the EDS. You see silicone, sulfur, carbon, oxygen, zinc, and barium. And it was later found out to be barium sulfate crystals that were making the water cloudy, and not a diatom, which many groups thought that it could be a diatom. Okay, so this new technology, and they helped us to collect the data so that you can determine what exactly is happening in the environment. Is it an algae bloom or not? So what's new for fiscal year 2023? We'll upgrade the FIDO app, refresh the PMN website, upgrade database and data visualization, partnering with the Gullah Geechee community and other indigenous communities in the United States. So we get full participation, especially from subsistence farmers. Partnering with Florida School of the Deaf and the Blind, and partnering with the HBOI Queen Conch Aquaculture Co-ops. I just want to give a special thank you to our collaborators in Louisiana, a part of the Louisiana University Sea Grant, Louisiana State University Sea Grant. Brian Callum, Riza Inselman, and Melissa Boston have been great supporters of this program. And I just thought that they deserved a special shout out for being on the front lines and monitoring their coastal water quality. And we're developing a monitoring program with LumCon as well. They are also very interested in doing this regularly. And so I just want to give a special shout out to them and thank them for their collaboration. We're looking to learn from what they find as well. Thank you all. Yeah, here are some images of the team. I missed that. That's Steve Morton. We have Jennifer Moucher Fuquay. That's me over there. And we have Andrew Schiller. Okay, so if you send your sample, this is the team who's going to be analyzing it and getting back to you with more information or research questions. And this is also Jordana Kutahar, who worked with us during the ending of her master's degree and was very supportive of spreading information about the aquaculture section of the Phytoplankton Monitoring Network in Texas. So if you have any questions, please let me know. And thank you all for listening.
Thank you so much for that presentation, Nia. Okay, so I'm going to have you stop sharing your screen, and we're going to have Brady Skaggs sharing about harmful algal bloom monitoring efforts in Lake Pontchartrain. Okay.
Hi, good afternoon. Thank you so much for having me, Emily. It's great to talk about our work over the 2019 time period and discuss a little bit about what we observed and what occurred. So I am Brady.
Oh, Brady, I'm not sure what happened, but you're muted.
Oh, I'm sorry. I hit the wrong button. I am Brady Skaggs. I'm with Pontchartrain Conservancy, formerly of Lake Pontchartrain Basin Foundation. And we are an environmental not-for-profit group that is centered around being a prosperous and resilient region. And we drive that through scientific research and then informing education and advocacy. As I said, that's me on the right. I'm originally a North Florida native talking about problems here in Louisiana. I am going to mispronounce some words, so I appreciate your patience and bearing with me. Come on, slide deck. Here we go. So in 2018, we had a algal bloom as the result of an opening of the Bonnie Carey spillway. 2018 flood event helped us to understand in the observed bloom that there were some serious issues that could arise from a HAB event. We didn't have anything at the state or local level related to either the biomass of HABs or toxins. So it was really like Christmas morning to have the 2019 microcystin and cylindrospermopsin recreational water criteria that were released or promulgated early in 2019. 2019 was a particularly odd year. And we were the public face for a lot of that, at least public information. Our colleagues at the Louisiana Department of Health had issued a statement and a press release saying to avoid any algae on Lake Pontchartrain. They released a satellite image to accompany that statement. And then it went along the lines of, the Louisiana Department of Health also warns that fish caught from Lake Pontchartrain should not be eaten during this algae bloom, and to urge and keep pets away from the water as well. So while the criteria was a great set of tools, oftentimes in that public engagement piece, we would also have to talk to folks about the limitations of the criteria, particularly in that it didn't give or assign any safety criteria or assessments for inhalation. So I do remember very vividly, there was someone that called and said, I plan to go this weekend onto the lake and take the PT boat tour. My child is very asthmatic. Is this something that can cause a problem for my child? And that was certainly a question that we couldn't answer because inhalation or that type of exposure wasn't accounted for in the criteria. And then certainly there's nothing in the criteria. It is swimming only, related to the consumption of fish or shellfish. So again, for folks that called up and said, well, I really want to eat either fish or shellfish out of the lake, is that safe for me to do? It was certainly problematic to try to relay any of that information with any level of certainty. So we have been around since 1989, as I had mentioned, but we had completed sampling activities in 2008 and 2011 as a result of the opening of the Bonnie Carey spillway and release of Mississippi River water into the estuary. But most of those assessments had never used anything that was HAB specific. They had all been classical water quality parameters, and specifically looking at dissolved oxygen, since HAB events can also be a hypoxic event. The Bonnie Carey spillway, for those that are not residents of Louisiana, is usually a 1 in 10 year event. But we have had 6 openings within the past decade. We've had back-to-back years in 2018 and 2019. In 2019, it was open twice, and it was certainly the longest year of open duration that allowed a large influx of nutrients from the Mississippi River, nitrogen and phosphorus, into an estuary that's open to the Gulf of Mexico. So it's a fairly rare event. We have a sampling program that is routine. We collect samples primarily at different recreational sites. We look for fecal indicator bacteria or some other classical water quality parameters. But in the 2019 opening year, starting in June, we started sampling for HABs and HAB parameters at 4 different sites on the North Shore and primarily 2 different sites on the South Shore. LP12 should also be included, which is the New Canal Lighthouse. But we worked in the field to collect these measures, and then we transferred these samples to our colleagues at Louisiana State University, principally Dr. Bargu's lab. And on top of the usual indicators that we collect for, microcystin was done by ELISA. A bevy of different nitrogen species was done. Phosphorus, silicates, and TOC, or dissolved organic carbon, was also measured throughout these samples. One of the really cool things that we really enjoyed, I guess starting in 2018, we had the opportunity to connect with Dr. Stumpf, and he pointed us to cyan and some of the great products that were working. He didn't really talk too much about the Pontchartrain specific experience, but as I remember, 2019, he developed that product entirely as in response to the opening of the Bonnie Carey spillway and trying to get satellite imagery as a result of that activity and opening. So for us, this was a fantastic tool because we could see information over a very large estuary. Lake Pontchartrain is 630 square miles. And when we go out and collect our routine samples, that effort usually requires 2 sampling teams to go out and collect that information, typically on Tuesdays, because we're working around a fecal bacteria hold time. So it's such an expansive area that it takes 2 sets of samplers to go out and to be able to collect those samples and get them to the lab prior to the expiration of that particular parameter's hold time. So seeing these satellite images was a fantastic kind of first opportunity, at least for me. I did not have the Android app because I am a very ham-fisted iPhone user. So having the satellite imagery in this product available through NOAA's website was absolutely a great tool that could help us if we needed to do some targeted sampling related to that opening. And you can see by the MODIS image or the true color image, the plume of sediment that is coming as a result of the opening in the southwestern quadrant of Lake Pontchartrain. And then you can see some of the bloom off to the east in the Mississippi Sound, just off the coast. And over the course of several months, we had an opportunity to see the intensity of these blooms change and progress. So what is significant about this particular image is that July 16th was shortly after Hurricane Barry made landfall to the west of us in southern Louisiana. We had an extended period of cloud cover, and for all intents and purposes, the first date that was available that we had a nice crisp image from the satellite showed no ongoing or no particular HAB event within Lake Pontchartrain. As I mentioned earlier, there were 2 opening events. So as the summer progressed and we got into that very hot, very stale August heat, there was certainly an opportunity for extensive periods of time where there was lots of sun and lots of clear sky, hot waters, and extensive bloom. Again, Rick can probably explain the cause of these imagery issues, but we had access to this product once a day on any given time. And sometimes we either had extensive cloud cover or there was a glint as a result of the angle of the satellite. I'm not going to pretend to know what I'm talking about, but as a person that was looking at whether or not it was a good opportunity to deploy our samplers and collect anything in a specific target, sometimes the satellite imagery was a little unusable. But overall, a great and fantastic tool. I do have 2 images of the predominant species, Anabaena. I'm not going to even pretend to routinely or appropriately pronounce Diclospermum. I usually just default to Anabaena, but we also had Microcystis. One of the very interesting things about this particular event was that Dr. Bargu had been sampling in the estuary and events prior, and there's usually a progression to the predominant species or species that are observed. I think as early as 2008, there was some research that she had published that it was usually a diatom or freshwater species, and then it progressed along the way. In this particular period of time, we had both a nitrogen fixing species and a non-nitrogen fixing species occurring at the same time in very abundant concentrations, too numerous to count in a lot of cases, which was absolutely remarkable that we had such a enormous amount of these microorganisms. Just to kind of show you some of the distribution of different samples across the timeline or the summer of 2019, the highest that we got to was about 6 parts per billion total microcystin. So that's well short of the 8 parts per billion microcystin that's recommended as the criteria from EPA. But the average or the mean average across the sampling site was well below 1 part per billion, and in fact closer to 2 parts per billion average at site 8. As far as some other data that we were able to capture, this kind of aligns with a lot of the scientific literature for other such HAB events. The total concentration of microcystin does not necessarily correlate with other water quality parameters in a nice, clean, well-fitting R value. So microcystin did not have or demonstrate a relationship to salinity, water temperature, or some of the other classic water quality parameters like dissolved oxygen. What is exceptionally interesting is that we also had colleagues from Tulane University do some genetic testing on these samples, and the microcystin MIC-E gene was certainly very pervasive in a lot of these samples. So every sample collected over the course of our sampling program had the microcystin gene, or a target microcystin gene present in those water quality samples. Really, really fascinating relationships related to an abundant number of copies from the MIC-E gene that was present in the water quality samples. Lake Pontchartrain sample site 8 had the highest microcystin concentration. And again, there was a positive relationship between phycocyanin and microcystin. MIC-E genes were in all samples, and certainly on the order of tens to hundreds of thousands of copies per liter. So one of the things that was certainly interesting as well is that we had microcystis and Anabaena in huge concentrations. We did qualitative assessments, or I should say Dr. Bargu did qualitative assessments of the species that were in our water samples. We did not, as a limitation, measure cylindrospermopsin or saxitoxin or some of the others, but we did not have any exceedances of 8 parts per billion or 8 micrograms per liter microcystin in our water samples. Some other interesting observations too was that the bloom disappeared or appeared to disappear after the occurrence of Hurricane Barry. And we really found the satellite imagery very useful as far as noting whether or not to collect and analyze samples in an otherwise very difficult or costly endeavor of deploying field teams and getting samples to Baton Rouge for analysis. Just to kind of wrap up, we had lots of folks that were involved in the summer of 2019, either collecting samples or performing analysis. And certainly you can see those folks here, but it was a very large and difficult effort to coordinate. So wanted to recognize everyone's efforts. That's all from me, Emily.
Okay, great. Thank you so much, Brady. I'm going to ask you to stop sharing your screen, and I will begin sharing mine. All right, so we're going to start moving into our question and answer period. I want to thank all of our guest speakers again for sharing their knowledge with everyone. And I also want to give another quick shout out to Melissa Castleberry from Louisiana Sea Grant. She's also part of my support team who's online today. So Melissa, thank you so much for helping make everything run smoothly and making sure this got well advertised. All right, so we're going to have questions for our guest speakers now. And also, I just want to pull your attention for just one moment before we get into that with this opportunity to provide feedback. So you can use this QR code if you'd like. I'm also going to put in the chat the link to the evaluation as well in just a moment, but you can take note of that QR code and provide feedback. Let us know what you think of this webinar on harmful algal blooms. Remember, we have another webinar coming up on November 3rd, which is part 2 in this 2-part series, and we'll try our best to take into account any feedback that you provide to us. All right, so with that, we're going to see if I can get back to my previous slide. There we go. All right, so we've got some questions for our guest speakers. Some of you sent them in ahead of the webinar. Some of you have typed them into the chat. So I'm just going to start out with what's in the chat for the very first question. Is the EPA working on recreational levels for anatoxin A and saxitoxin?
Well, hi, Emily. So one of the challenges that we've had with, so those 2 toxins are also toxins of interest in addition to the microcystins and cylindrospermopsin. One of the challenges we have is data availability, particularly on the health effects side. And so one of the reasons we didn't include those with the initial round of recommendations was that we were lacking data to be able to develop a number that would be safe. And so since we issued the initial cyanotoxin criteria, we have continued to collate and evaluate data as it becomes available. And at this time, we're not working on actual development of values, but we continue to look for additional data that might support that in the future.
Okay, great. Thank you so much. Another question that we have from the chat, does the water body have to be large for the satellite to pick up a bloom?
It depends on the resolution of the satellite. So about 3 pixels wide is the rule of thumb. So the Ultra data we're using would mean with 300 meter pixels, it needs to be 900 meters wide in order to extract a bloom. If we had higher resolution, we could go to a smaller water body.
Okay. All right. I'm going to bounce over to a question that we received from the registration. Questions for speakers. Are there any plans for a regular state level monitoring effort of HABs? Do we have any insights on that? I'm wondering if this might not be directed at you, perhaps, John?
I thought the question was about state monitoring.
Yeah, I guess I'm wondering if maybe this person was wondering if there might be some federal oversight on that.
Not per se. We recommend the values for states to adopt and use. For Clean Water Act purposes, various Clean Water Act purposes, but we don't prescribe how that needs to occur. And so, if a state asks me a specific question, I might send them to somebody like Rick to plan out an approach that might be useful, including the satellite data as well as on the ground sampling. So we don't prescribe a certain approach that a state might use. It might depend on their resources available and what they're able to, where they have problem areas, how extensive those might be. So it would be better off to direct the question directly to the relevant state agency that might be responsible as well.
Okay, yeah, that makes sense. Another question that we received, have you compared your satellite products with field data? How to identify HAB species from other phytoplankton species in satellite data? Rick, are you speaking? I think you might be muted.
Yes, we have done comparisons. Cyanobacteria are the most effective, and we have a number of papers on comparisons with cell counts. We've actually, while we cannot detect toxins from satellite, we have found a very high relationship nationally between cyanobloom presence and toxin presence in the country. On other HABs, right now it depends on identifying the HAB does require some field data. So many dinoflagellates and diatoms have a same pigment suite, so they cannot directly be separated. And of course, dinoflagellates, which are the most common HAB formers, not all of them are toxic. as well. So typically what we're working on is looking towards ecological relationships, geographic relationships to pull that in, and then potential cell count. So something like the phytoplankton monitoring network actually can be an asset. We can identify a bloom. We can say it's likely to be a dinoflagellate or a diatom, and if we can get a confirmation, then we have a basis to track it using getting some other information in. So say like, we've actually worked with PMN a few times saying, we've got this bloom, we're not sure what it is, can you get a sample? And then we can then identify it from there, track it from there.
Thank you so much. An additional question was, what sort of data would be most beneficial to forecasting efforts?
Most critical for a forecast is, where is it now? You can even step back. If the most common forecast people know is the weather forecast. If you don't know the weather today, you can't possibly forecast it tomorrow. And that's, we do need to know where it is. One of the reasons we work so hard with the satellite data is it gets a synoptic view and gets us data in places where it's not possible to collect it from the field. After that, it's a question of what you want to forecast. If you're looking for where will the bloom be in the next few days, having a numerical model that allows for transport, then allows you to do that distribution over time. If you're asking a larger question of what is it likely to be this summer, that requires more ecological work on the body of water as to expected conditions. I think, for example, Lake Pontchartrain with the Bonnie Carey Spillway, there's probably enough data now. Well, we can pretty reliably say there will be a cyanobacteria bloom in Lake Pontchartrain after it opens, but maybe the question is how soon after and how intense it will be, might be the questions that would come up. But those require that ecological context in order to do that. Shorter term are easier as long as you can find the bloom to begin with, because you just need to move it around at that point. Over several days, growth and death and mortality usually aren't factors in that regard. So that would help. There's a lot more to it, but that's probably the shortest answer I can give.
I like it. No, thank you. That was very it was a very detailed answer. I appreciate that, as I'm sure do our audience members. An additional question that I have for you all from our audience members. Someone wrote in, interested in current research exploring the relationship between major hurricanes on the WFS, maybe weather forecasting system, I'm guessing, and severity of HABs in subsequent years. Could any of you provide any insight on that?
From this year into future years? That's the question?
I think so.
Ooh, that's really hard. Hard enough to say what the HAB's going to be, let's say, you know, in a few months. Trying to say what will be going out. I mean, there's been a few efforts that I've seen on trying to look at large picture climate. Maybe that's what they're getting at, but the relationships are not so good. Yeah, that's a hard one.
Okay.
That's where people would like to go is, well, how will it be next year? And we don't have a particularly good answer.
Okay. Yeah, thank you for that thought that you put into that response. What are the best molecular methods to detect algal toxins? Are things like qPCR or dPCR or sequencing? Is there a particular tool that might be better than the others?
I think I might be able to start this conversation. I can't say which is better. There's certainly limitations to any technology, as there are some advantages. What would be nice is if, you know, all the folks that are researching this particular set of compounds could get together and inform a change in one of the books that we always go by when we're designing a sampling program, Standard Methods for Water and Wastewater, Standard Methods for the Examination of Water and Wastewater, which is the gold standard as far as developing a sampling program. So if there is a standard method, whether it's ELISA-based or HPLC, you know, it'd be nice to have something that would help us to normalize and compare data across the country or across different projects.
Okay.
And Emily, just to kind of build on that response. So from the question, there are different endpoints one can monitor for. So Brady had mentioned ELISA and HPLC, and those are geared or designed to detect the toxin in the water. And so, you know, ELISA is a good method to use. There are some drawbacks with HPLC and standards, even though it's a little more sensitive. But then there are also endpoints where you can look at the presence of the genes in the cells that might be present. So I mentioned the toxigenic cell population. And if you wanted to monitor, like the state of Ohio does, look for the presence of the gene and how many gene copies are present to give you an idea of what the toxigenic cell population can be, that's a qPCR based method. And, you know, there's the drawbacks with molecular methods for detection of these genes can be the expense associated with it, the expertise needed. But there are standards that you could use that are commercially available for this. I'm not aware that's been adapted for a digital PCR platform yet, but could be. I'm not saying that it can't. I don't know if that's commercially available yet. Researchers might be using that, but yeah. So you can search that online for looking for the toxin genes, and there are various sets or primer sets that are available for looking for microcystis gene sets, cylindrospermopsin, I think saxitoxin, and maybe anatoxin A, or the four that I think are available commercially, and you could look at those. Ohio has had some luck being able to some success being able to detect the elevation of the gene copies relative to when in advance of the increase in the concentration of the toxin present. So that can give you a little bit of early warning. I think they have a couple week lag. I think the last time I had seen a presentation by folks there, but that couple weeks could give you a heads up. And as Brady was saying, to design your monitoring sampling approach, if you had a couple week lag, you might be able to know like where to specifically monitor and focus your resources. So that could be helpful as well.
Excellent.
I just wanted to add in the analytical response team here in Charleston does use the methods that were mentioned earlier, the ELISA kits. They also do the receptor binding assay, as well as using LC mass spectroscopy, liquid chromatography mass spectroscopy. So those methods are currently in use. Just to add on to that. And in addition, that's why the PMN program is really useful in getting more frequent monitoring, because we can detect the potentially toxin producing species in hopes to get an early warning on the potential for a toxic event. Just wanted to add that in. So the more monitoring we can get, the better prepared we would be to be able to forecast, if you would say. It's not a perfect method, but it's really helpful to have support from the community. We get a head start on this toxin production.
Excellent. I really love how you all chimed in. This is a really well-rounded response to that question. There was someone that wrote in, apparently I don't know my acronyms, WFS from one of those previous questions is not weather forecasting service, it is West Florida Shelf. So keep that in mind when reviewing that previous response. just to let you all know, I think that it was mentioned at the very beginning, but this webinar is being recorded, so you can go back to it later to refer to different presentations that you were interested in, or different responses during this Q&A session. The link will be shared with you all after the webinar. So just a couple more questions and then our guest speakers will be released. So is there any connection between the types of algae and the filter feeder population decrease? I have read that Gulf menhaden are not overfished, but at the volume being caught, I've wondered if there's a connection between the volume and the rate in which they're fished and algal blooms. I'm not sure that anyone's presentation specifically spoke to this, but if you all have any thoughts, there is someone out there who was curious. Any takers? Going once, going twice? All right, one more question, then a couple of quick announcements. So there's a final question about nutrients. Are satellite data available for nutrient compounds? Also, are accessory pigments other than cyano-based pigments available, such as fucos or xanthos?
On nutrients, their nutrients are not detectable by satellite. Surrogates have been used. So if you have a bloom, there's so much nitrogen and phosphorus in the bloom. So you can potentially infer that, but you have to be careful when you go into sediment because you end up with a very different distribution. But to dissolve like nitrate, orthophosphate, they can't be picked up because they have no color in the wavelengths we work with. And on pigments, other pigments it potentially can be picked up, but you need what's called hyperspectral, which is, I had an example spectrum, which was every couple of nanometers. And then there are variations, particularly from the blue into the green, where the various carotenoids particularly tend to absorb, and they produce bends in that signature, which if a hyperspectral sensor were used, that'd be possible. Right now, from satellite, there's very limited. There's a couple of one or two CubeSats that get occasional imagery. NASA's going to put up the PACE mission launch. It's I guess in two years. Within 2 years from now, that will be 1 kilometer hyperspectral, and that'll be the first routine hyperspectral mission. That a big question is how well can we do with the carotenoids at that point, and that may open up new opportunities.
Okay, well, thank you very much. One silent round of applause for all of our guest speakers for sharing their knowledge again. Again, this webinar is being recorded, so you'll be able to refer back to it and all of the presentations. I want you to check out in the chat. We have both the feedback link as well as registration link for part 2, which is happening on November 3rd, Thursday, November 3rd from 1 to 3 p.m. Central. I just want to thank you all for taking the time to tune in and to share your questions and for your attention. Please feel free to reach out to me at edouglas with 2 S's at lsu.edu if you have any questions. And thank you again.